So in this video, we will be covering the important questions from continuity. Students, if you solve these questions, I can guarantee you 4 marks in your board examination, IP examination. So kindly watch this video carefully and do practice the homework question towards the end. Okay, without wasting much time, let us go with the first question. So he's telling, check the continuity of the following function at 2. Before we solve these type of questions, let us quickly recall the definition of continuity. It says limit x approaches to a f of x if it is equals to f of a, right? I repeat. Now, what does this mean? This means limiting value of f of x, and this is value of the function, value of function at x equals to a. If these two are equal, no, then we can say that f of x is continuous. So students, I recommend you to pause the screen and note down this definition, and please remember this definition. We will be using this definition in all the questions. Okay, I'm now erasing it. Yeah, so the first question says that we need to check the continuity of the following function at 2. That means here we need to check it around 2, right? That means a is equals to 2, right? So here we need to check the left hand limit and right hand limit separately, because x equals to 2 is given. The value of the function at x equals to 2 is 0. That means f of 2 is 0. Replace x with the 2. So we get f of 2 as 0. I hope this is clear. So this is the value of the function. This is the value of function at x equals to 2. Now we have to find the limiting value at x equals to 2. To find the limiting value, we have to find the left hand limit separately and the right hand limit separately, because here we have multiple definitions. So for left hand limit, that means limit x approaches to 2 from left hand side. So we write that as 2 minus f of x. Now which definition shall we use? We have 3 definitions. First definition, second definition and third definition. Which definition fits in better or the best here? So limit x approaches to 2 minus. See, 2 minus ante 2 kante takku kada. So 0 less than x less than 2 ante 2 kante takku ante 1.9 1.8 avanni ikkada ostayi annamata. So manam ee definition తీసుకుంటాం first function ki. Is that clear? So we can write here half of, instead of f of x I can write half of x square minus 4, right? Now as x approaches to 2 from left hand side, x square minus 4, this will x square will approach to 4, because 2 square is 4. 4 minus 4 divided by 2, so this is indeed 0. Not just that, we have to find right hand limit, and we have to write limit x approaches to 2 plus f of x. Now dear students, which definition shall we use here? X should be greater than 2. Clearly the third function we will be using here. So we will write this as limit x approaches to 2 plus f of x. Instead of f of x I can write 2 minus 8 x power minus 3. We can write 8 by x cube. I hope this is clear, right? Is this clear? Yes. So now this will be nothing but 2 minus, replace x with 2. As x approaches to 2, x cube will approach to 8. So this will be 2 minus 1, which is 1. Now left hand limit is 0, right? And right hand limit is 1, right? So therefore LHL, left hand limit, is not equals to RHL. Thereby we say f of x, so we can say limit x approaches to 2 f of x does not exist. So we can say, since limit does not exist, we can say f of x is discontinuous at x equals to 2. At x equals to 2, f of x is discontinuous. I hope you understood this. Is it clear? Yes. Now let us go to the next question. It says, check the continuity of f given by f of x equals to this, right? F of x is if 0 less than x less than 5 and x is not equal to 3. and if x equals to 3, we have the function as 1.5 at the point 3. So again we have to find, let us first find f of 3. Now dear students, you should be able to say what is the value of the function when x is equals to 3. Clearly it is 1.5. It is very simple. Directly write down 1.5. Now we have to find limit. Unlike the previous question wherein we found a left hand limit and right hand limit separately, here we need not, because we only have one definition for 0 less than x less than 5, or we can simply say when x is not equals to 3. So we have only one definition. So directly we can write limit x approaches to 3 f of x. Now when x is not x approaches to 3 means x is not equal to 3. So we can write limit x approaches to 3. Instead of f of x, we can write x square minus 9 divided by x square minus 2x minus 3. I'm writing this definition, dear students. So now I think we can factorize it. We can write the numerator as x minus 3 into x plus 3 divided by x square minus 2x minus 3. We can write it as x square plus x minus 3x minus 3. We can write this as limit x approaches to 3 x minus 3 by x plus 3 divided by, I can take x common here, so we can get x plus 1, and we can take minus 3 common here, so we will get x plus 1. Now we can write this as limit x approaches to 3 x minus 3 into x plus 3 divided by, we can take x plus 1 common from the denominator, and now what remains is x minus 3. So we can comfortably cancel this and this. So now what are we left with? We are left with limit x approaches to 3 x plus 3 in the numerator and x plus 1 in the numerator. Now we can comfortably replace x with 3. So we can say 3 plus 3 divided by 3 plus 1, which is nothing but 6 divided by 4, which is nothing but 3 divided by 2, which is nothing but 1.5. So value of the function is 1.5 and the limiting value is also 1.5, dear students. So what can we say here? Since limit x approaches to 3 f of x is equals to f of 3 and that is equals to 1.5, therefore f of x is continuous at x equals to 3. I hope this is clear. Now the next question says find real constants a comma b so that the function f is given by this is continuous on all real numbers, dear students. Whenever they say it is continuous on all real numbers, we have to see the end points where the function is breaking, right? Here in this question, unlike the previous questions, he is telling that the function is continuous everywhere. That means the function should be continuous at 0 also, function should be continuous at 1 also, function should be continuous at 3 also, right? So let us write, since f of x is continuous when x equals to 0, we can say limit x approaches to 0 f of x should be equals to f of 0, right? Correct na? So I hope that is clear. Now here when we say limit x approaches to 0, since we have multiple definitions for around 0, that means if x is less than 0 we have one definition, and if x is greater than 0 we have one more definition. We can write limit x approaches to 0 minus f of x. Now this is left hand limit. I hope you understood this. This should be equal to limit x approaches to 0 plus f of x. This is right hand limit. Now this should be equal to f of 0. Is this clear? Yes. So what for left hand limit, which should be the function? What should be the function? That means x should be less than 0, na? So that means we should be taking this function. So we will write limit x approaches to 0 minus, instead of f of x we'll write sin x. And for right hand limit, what should be the function? X greater than 0. So that means now here 0 less than x, that means x is greater than 0. So we will be taking this definition, right? Second definition, x square plus 0. And what will f of 0 be? F of 0 also will be sin 0. Why sin 0? Because x is either 0 from the first definition or x is less than 0. I hope you understood this. Now from here what do we get? Sin 0 is 0. And here we can replace x with 0, we get 0 plus a, and sin 0 is again 0. So comfortably we can say that a is equals to 0. I hope you understood this, dear students. Now let us go with the next part. Since f of x is also continuous at 1, right? Since f of x is also, since f of x is, so for 1, yeah, since f of x is continuous when x equals to 1, we can say limit x approaches to 1 minus f of x. That will be equal to limit x approaches to 1 plus f of x, and that should be equals to f of 1. Now when x is less than 1, right? X approaches to 1 minus means x should be less than 1, right? Less than 1 means we should be taking this particular definition, correct na? Because x is less than 1. So we are here, we can write limit x approaches to 1 minus, instead of f of x we can write x square plus a. A is anyways 0. I hope that is clear, right? A is anyways 0. Now that should be equals to limit x approaches to 1 plus, and what is f of x here? When x is greater than 1, we will be taking this definition, that is bx plus 3. I hope you are following this. If you are not following, please rewind the video and watch it. Here is telling that 1 is less than or equal to x, that means x is greater than 1. And when x is equals to 1, again we will be using this definition only, because x is either equal to 1 or x is greater than 1, right? That means instead of bx plus 3, here we will be writing b into 1 plus 3. In place of x, I am writing 1 for this definition. F of 1 is this, right? I hope you understood this step. So replace x with 1 here, we get 1 plus 0, and that should be equal to b plus 3, right? That is equals to b plus 3. Now let us equate these two. We can say 1 is equals to b plus 3. That means b should be equal to 1 minus 3. It should be minus 2. I hope this is clear. Now if you want to verify the right hand limit, still, so x should also be continuous at 3, right? X should also be continuous at 3. So we get, you can quickly check it, since f of x is continuous, or let us check the continuity at x equals to 3. So dear student, this step is an extra step. You need not write this extra step in the examination, so directly I will do it here. This you need not write. So limit x approaches to 3 minus f of x. F of x will be, b is anyways minus 2, right? So we'll write minus 2x plus 3. So what is this value? So minus 2 into 3 is minus 6, minus 6 plus 3 is minus 3. And limit x approaches to 3 plus is anyways minus 3. So anyways limit is equal. That means the value of b is correct. So that you can just use for is this as a check, right? Anyways, this you need not write in the examination. The solution ends here only, okay? Now let us go with the next question. It says, show that f of x is given by this, where a and b are real constants, okay, is continuous at 0. That means we have to show that limit x approaches to 0, f of x should be equals to f of 0. Now firstly let us write f of 0. What is f of 0? That means when x is equals to 0, f of x is, that means f of 0 should be this function, no? That is half of b square minus a square. Now let us just find the left hand side of the equation. That means limit x approaches to 0, instead of f of x, when x is approaching to 0, that means x is not equal to 0, we will be taking this function, that is cos ax minus cos bx divided by x square. Now dear students, all of us know what is cos c minus cos d. Cos c minus cos d is minus 2 sin c plus d divided by 2 sin c minus d divided by 2. So dear students, please note it. This is a very important formula, okay? So cos c minus cos d is minus 2 times sin, c is ax, d is bx, ax plus bx divided by 2, and then sin ax minus bx divided by 2. So dear students, we'll do one thing. X square will write as x multiplied by x. Let us take this minus 2 outside, okay? So we get minus 2 times limit x approaches to 0. We can write this as sine of a plus b by 2 times x, okay? I hope this is clear. Divided by x into sine of, again, a minus b divided by 2 into x divided by x. I hope this step is clear. Now we know that limit x approaches to 0, sine x divided by x is 1. So here if I have x and x in the denominator, it should be 1. But here instead of x I have a plus b by 2 into x. So what will I do? I will multiply and divide with a plus b by 2. I hope you are following this. So we can write here minus 2 times limit x approaches to 0, sine of a plus b divided by 2x. Now I'll multiply and divide with a plus b by 2, right? So this is first part, and then the next part is we will multiply and divide with, yes, you are correct, a minus b by 2, right? I hope this is clear, right? Now limit x approaches to 0, sine of a plus b by 2x by a plus b by 2x, this will be 1 and this also will be 1. So what will the final answer be? Minus 2 times, this is remaining a plus b by 2 into, again this is also remaining a minus b by 2. This and this gets cancelled. we can take this minus here. We can write it as a plus b into b minus a divided by 1, 2 is remaining, no? Now b plus a into b minus a should be b square minus a square by 2. So this is equals to f of 0. F of 0 is half of b square minus a square. Let us say this is 1 and this is equation 2. What is this? This is f limit x approaches to 0 f of x, right? So this is nothing but this is limit x approaches to 0 f of x. So we can say that from 1 and 2 we can say limit x approaches to 0 f of x equals to f of 0. Therefore f of x is continuous. F of x is continuous, hence proved. I hope you understood this. Now the next question, let us take it as a homework. If the function f defined by f of x is continuous on R. Acha, he's asking, is the function f of x defined by this continuous on R? So you have to just check whether limit x approaches to 1 minus f of x is equals to limit x approaches to 1 plus f of x, and whether that is equals to limit, not limit, it should be equals to f of 1. I hope now you can do it. Please try this as a homework question. And please do type the answer in the comment section. And we have one more question. Is f defined by this continuous on 0? Again, we have to find limit x approaches to 0 f of x, whether that is equals to f of 0 or not. If it is yes, then we can say it is continuous function. So again, this also is a homework question. Please do comment the answer in the comment section. Thank you for watching this video.